number. Let us see. Yep, it's not a real number, it's an imaginary number. Well, it's real enough to me, but they call them imaginary numbers. Yeah, we'll get an idea of how this thing goes. Okay, in terms of I, what are these?
Would the first one be 6i?
Yep, because it's like root. Hang on a second. So come on, penny. There we go. You could write it as root 36 times root 1. Sorry, root minus 1.
Yeah.
And so that would be 6i. The second one.
Then 2 root 7i.
2 root 7i. 2 root 7i. There you go. Sure. Okay, let's add and subtract.
So the first one is 9 plus 8i. And then the second one is 16i minus 3. Wait, no, 6i. 6i minus 3.
Yep.
And 10 minus 16i. 5 plus 3i.
5 plus 3i. Looks good. 10 minus 16i, 5 plus 3i. They're all correct there. Do not use your calculator in this exercise. Why would you say that to me, Bookie? Okay. What are we doing here? Z1 is the find A and B.
So first you should like substitute Z1, Z2 into that equation. So you'd have minus 3 plus bi minus a plus 9i is equal to 7 plus 2i.
Is that
it? Shouldn't they be in like brackets? So
yep, just check it.
And then you just like, I don't really know, but you just like look at it.
Yeah, called by inspection.
So, you know, minus 3 minus a is equal to 7. So a is equal to minus 10. And then b is equal to 11.
Probably is. Minus 10 and 11. Great. If b squared minus 4ac is less than 0, then there are no real roots, but there are two distinct complex roots. So if b squared minus 4ac in the quadratic formula is greater than 0, then you've got two distinct real roots. If it's less than 0, then you've got two distinct complex roots. What's this about?
9. So this would be like z plus 3, z minus 3, because it's like the 2 square. Wait, that's only when you subtract. Never mind. I guess you could see z squared is equal to minus 9. And then you could square root both sides, so then you just have like 3i.
3i. Oh, not squared, just 3i. And this will sound weird, but is there another very similar number that when you square it, you will also get minus 9?
Minus 3i?
There you go. plus or minus 3i. Any questions about that?
Not really. It's a bit weird, but it's not that bad.
Mm-hmm. How's about this?
You basically just do it the same way.
What's the same way?
Like you basically just, I don't know, you just do it like the same way as like a normal one. And then you just put I.
Yep. I like that you're holding your calculator.
Yeah, I didn't have a calculator.
Are you using graphical?
Yeah, but I don't know how to do it because it says no real roots.
Change the setting to allow imaginary stuff. Let's see.
I don't know how to do that.
So it'll be in settings.
Oh, there, complex mode, I think.
Yeah. And it should say A plus BI at the top.
Yeah, I pressed it.
There you go.
4i minus 3 or minus 4i minus 3.
So is that plus or minus 4i minus 3?
Yeah.
Minus 3 plus 4i minus 3 minus 4i. Simple calculator gets it. And this calculator gets it as well. And that's A plus BI mode. Sorry. Any questions there?
No. Get it.
All right. Do not use your calculator. Here we go.
Use the formula. Wait, has two distinct. Oh, so you know b squared minus 4ac is less than 0.
Very good.
So you just do b squared minus 4 times z times 11.
Mm-hmm.
Is less than 0.
Hang on. Minus 4 times what times 11?
Oh, times 1.
Yep.
So that's just b squared minus 44 is less than 0. So b squared is less than 44. And then you square root both sides.
Mm-hmm.
So b is less than root 44. I. Is it I? No, it's just root 44.
And is that 2 root 11?
Plus minus. Would it be plus minus root 44?
Yeah.
Yes. Yeah.
That means b is less than plus or minus 2 root 11. And let us get fancy. No, something's wrong. You're half right.
Why?
B is less than 2 root 11. But B is greater than the negative one. For the negative one, sign will change. The inequality.
Oh, yeah. Right.
And so it will be minus 2 root 11 B positive 2 root 11. Or if you are very, very, very fancy, I think you say the magnitude of B is less than 2 root 11.
Mm-hmm.
I'm not very fancy. Let's see. Here we go. B is in between those two. Or you can do a graph. Anyway. Any questions there?
No. Why would you do a graph?
This is the graph of b squared minus 4ac. Where is it less than 0? It is less than 0 between the roots. It's just a graphical solution. That's all it is. Okay, what is this? All right. Yep.
So it says you just do it the same way. So what do you do when there's two i's? Like when you do like 3i multiplied by 5i, do you just get like I squared?
Yeah. I is minus 1. What root minus 1? What is root minus 1 times root minus 1?
Oh, so that would just be minus 50. For the first one, I got 22i minus 7.
Okay.
I think it's right. The second one, I got 33 minus 56i.
Probably right. 33 minus 56i minus 7 plus 22i. Any questions there?
No, it is just the same as algebra.
Yep.
Um,
Had to get
okay.
weird.
I don't know about the first one, but is it like -1 times root -1?
Yep.
Is there like another nicer way to write that?
What is the square root of -1?
I? Oh, okay.
Simpler.
-1i? Or minus I, yeah.
Mm-hmm.
The second one's just 1. 32i to the power of 5.
Okay. What is 30? What is I to the power of 5?
I?
Yep. So what's the final answer?
Oh, so it's just 32i.
Yep.
So whatever like power is, so it's just like I or 1. Basically.
Maybe
Oh,
this was a negative one.
Yeah. Okay.
So it kind of swaps.
A bit confusing, but it's not.
32i minus I and 1. Any questions?
No, it's a bit confusing, but it's not that bad.
Yeah. Life is confusing. Let's see. How do we do this?
Would you just like substitute 1 minus 4i and then solve? Or would you just, oh wait, you just solve it. Never mind. Like normally.
You substitute 0 for f of z, not 1 minus 4i.
Wouldn't you just solve it though? Because it's like, it's equal to 0, so you just have to solve it.
Yeah.
Yeah, the calculator gives you 1 plus 4i and 1 minus 4i.
0 marks.
Quadratic formula.
Okay.
I don't know it by heart. I probably should. Over 2a. I remember that part.
I'm thoroughly disappointed.
I knew it in GCSE, but I don't know it anymore. So 2 plus minus 4 minus, I can't do that in my head. 68
Excuse me.
over 2. Somehow I have to simplify that. Wait, 4 minus 68 is minus 64, which is 8i over 2. So that's just 1 plus minus 4i.
4i equals x. And that's been shown. There's something about this question that's a bit ambiguous that I do not like. Show that z is equal to 1 minus 4i as a solution. You've done it. We've got full marks. If they had said verify that.
Oh, that's when you have to like substitute in.
That's when you'd sub it in. And to me, the obvious thing to do for this one is to just do 1 minus 4i squared minus 2.
Yeah, that's what I thought at first.
1 minus 4i plus 17 is equal to 0. Therefore, it's a solution. But I believe that would be 0 marks because it's not verified. It's show that, even though that does show it. But
Okay.
oh, hang on. I'm missing some exam questions, I suspect, as well as the answers. I have an idea. I might be wrong about this. So Gregoire, you did this there. No, I had the answers open, that's why. This will just be, maybe I'm wrong. I'm very wrong. We have everything. I'm eminently prepared. So what do you give yourself there?
A tick. It's somewhat different from like normal algebra.
Yeah. Complex conjugation. All you have to do is think of difference of two squares when it comes to rationalizing a denominator. So you have to rationalize a denominator.
Rationalizing, okay.
Yeah.
Okay.
So complex number z equals a plus bi. The complex conjugate z star is a minus bi. Let's see. Okay, z star, what is this?
2 plus 7i.
Yep. P.
Wouldn't the added one just be 4?
Yep.
And multiplied. Oh, that's difference of 2 squared. So it's 4 minus 49i.
Yep. Hang on. Something's missing.
Oh, 49i squared,
Yep.
which is plus 49i. I think.
What is I squared?
Oh, yeah. Minus 1. So it's 4 plus 49, which is 53.
What do you notice about the question? What do you notice about the answer for part C? What's the main difference between these numbers?
I in the question and there is in the answer.
Yep. So just like getting rid of a square root from the denominator in rationalizing the denominator, this is essentially rationalizing, I don't know, a complex number. I don't know, realizing it, making it real. Maybe that's what rationalizing means. Okay, how do we do this?
So you have to multiply it by 2 plus 3i.
Mm-hmm.
So then you get for the for the numerator. Wait, you have to multiply it by 2 plus 3i over 2 plus 3i.
Correct. Hang on. Yes. I wrote down minus by mistake. Sorry, I wrote down plus by mistake.
And for the So for the top, I got 23i minus 2.
Mm-hmm.
And then for the bottom, I got 13.
Write it in this form.
Minus 2 over 13 plus 23 over 13i.
Looks good to me. Minus 2 over 13 plus 23 over 13i. You think they'd start us off with an easy question?
That wasn't that bad.
Well, you know, with normal numbers. Yep. Any questions about that?
No.
Man, that me comparing this to rationalizing the denominator was just made that one too easy. Me and Gregoire were doing these questions. Ooh, I didn't know what I was doing. Okay, remember this one?
So you could just do like, I don't know what it's called, but you know when you like kind of like swap the denominator and the other one.
Sure.
So it's like 5 plus 2i over 2 minus I is equal to z. And then you have to multiply the fraction by 2 plus I over 2 plus I.
Yep. I don't think you need to do it. I think it's easier than the one we just did.
Yeah.
So I think you're going to be fine. Great. Okay, how about this one?
So you have to divide both sides by 4 plus 2i. So then you have like a fraction. And then you multiply the fraction by 4 minus 2i over 4 minus 2i.
Okay.
And then you multiply it out. So for the numerator, I got 32 minus 28i. And then I got 20 for the denominator. So you have to do the same thing, like 32 over 20 over their rational numbers. Oh, they are rational numbers. Okay. So you just do 32 over 20 minus 28 over 20i.
Full marks?
Hmm?
Nope.
Oh. Plus 2i.
Yep.
That's 2 minus. Oh, you should have 3 over 5i.
Why should I have 3 over 5?
Because 2 minus 28 over 20 is 3 over 5.
Oh. I just changed that one to 8 over 5.
Yeah.
Hold on. I'm gonna get some answers. What's this called? I don't know. Further maths or something? Here we go. Come on, bookie. Are we in C? Maybe we're in D. Question 11. Nope, we're in D. Must be. Or is it B? 4 over 5 plus 3 over 5i. Oh, what's this thing doing? Where did we go wrong?
You get minus 8i squared. But then that just comes 8. I don't know what went wrong. Yeah, so I got Why is it minus 8?
Isn't it 8I squared?
It's minus 8I squared. Because it's 6 minus 4I times 4 minus 2I.
What's a minus times a minus?
It's a minus times. Oh, okay. That's where it's wrong. Minus 8I squared. Yeah, it should be.
Okay. We know.
If you get minus 8I squared, and then I is minus 1, wouldn't it be plus 8?
True. If we got minus 8I squared, do we get minus 8I squared?
No.
Minus times minus plus.
That's 16 minus 28I.
28, yeah.
Yeah.
Testing it. And then you just do the rest as normal. Okay, any questions there?
No, I just don't know how to add.
It doesn't matter how good you get at maths. No one is ever good at minuses. No one's ever good with fractions. Especially me. Let's see this one.
So you just have to P minus 7I.
Too easy. Too easy.
Okay.
This is more like it.
So you have root 5 plus 4I over root 5 minus 4I, I think. Right? And then you just multiply by root 5 plus 4I over root 5 plus 4I. So then the top is calculator. I got 8 root 5I minus 11 for the top part. That looks wrong.
Why was it minus 5?
It's minus, I got minus 11.
How'd you get minus 11?
Because I got 5 plus 4 root 5I.
Yeah, sorry, that's going to be minus 16. Yeah, minus 11 is correct.
And then I haven't done the bottom, but it's 20 minus 5 minus 16. It's 21 on the bottom. Is that right?
21. And in their form?
Minus 11 over 21 plus 8 root 5 over, 8 over 21 I root 5. Shouldn't it be 8 like over 21 I root 5 or something?
Yeah, they want us to put it in a weird way.
Yeah, it's really weird.
8 over 21 I
root 5.
Root 5. Question 13. Minus 11 over 21 plus 8. Yeah, they didn't follow their own convention. 8 root 5 over 21i. Yep. Any questions about that?
No.
Nice to know they're asking us to do stuff they themselves are not even doing. See this one? It's a little different, alright.
The real part. I think you should like solve it first. And then you can find what P, well, you have to solve it to find what P is. So you have to multiply by P plus 2I. No, yeah. Over P plus 2I. I don't know what to do because I got, like, on the top I got P2i plus P5i. Oh wait, that's just P7i.
All right, it's 7pi.
Yeah. Plus P squared minus 10. And then the bottom, P squared plus 4 on the bottom. Okay. Well, you know that P squared minus 10 is equal to 1 because, like, it says the real part is a half. And then P squared plus 4 is equal to 2. Is that right, or is that not right?
Not necessarily, because a half is the same as 2 over 4,
Yeah,
3 over
that's true.
6.
I don't know how to solve this.
Is
Well,
P...
the first part is basically, like, the top one is like a quadratic equation.
Okay.
Okay, that's not helpful. I don't know how to do this.
Well, if you were to factorize the top, it would be P plus 5i, P plus 2i. That'd be going backwards.
Yeah,
So P is just a number, is that right?
I think so.
So P squared over P squared plus 4 minus 10 over
P
P
squared.
squared plus 4. And then you have the imaginary bit. 7pi over P
But I
squared.
think you can just ignore that because it doesn't really matter what it is.
Right. So how do we find P?
Solve that is somehow.
Like, so it has to be equal to something.
Yeah, I know. I know what it's equal to.
What?
It's equal to something times a half.
Why is it equal to something times a half?
Because it says the real part is a half, but
Okay.
it could be like another one, like 2 over 4 or 3 over 6.
This is the real part.
Okay. I still don't know what to do. Oh, but
This
you
is-
said you can't do that because it might be equal to, like, something else.
I believe you were saying like P squared minus 10 is 1.
Oh yeah, I will say that.
You know what I mean? But a half
Shouldn't
is...
you just couldn't you just put them on, like, one, like, combine into one fraction?
Mm-hmm.
Then you can cross multiply.
Mm-hmm.
I think. Wait, what? How did you do that?
You tell me to cross multiply?
Wouldn't it be P squared plus 4 is equal to 2 times P squared minus 10 if we cross multiply?
Oh, you cheek this man. Okay, we'll do it all in one go.
Is there another way to cross multiply? I did not even know that. It's just how I always do it. So 2p squared minus 20 is equal to p squared plus 4. So then p squared is equal to 24. So p is equal to root 24. Yay. Done. Right side in the form.
Hang on. That should be plus or minus.
It says p is greater than 0 in the question.
Ah, there we go. And write z in that form.
You would just substitute root 24 into that fraction.
Mm-hmm. Yeah, root 24. And it's the same as 2 root 6. And you just sub it in. Any questions there?
I mean, it was a bit confusing, but it's not that bad. Like, once I get used to it.
Yeah, I think because there's two different things on the denominator, And so
Yeah.
you just have to...
I just got confused because of like the I in the top bit, and then I didn't know what to do.
Yeah, so that would be the imaginary bit. I think as well that's the... Because you've got two things on the denominator. If you had one thing, I think you'd be all right. Complex conjugation.
Yeah, I get it. It's not super complicated.
Roots of quadratic equations.
Hmm?
Who knows what this is about? Okay, given that alpha is one of the roots with real coefficients, state the value of the other root.
I have no idea how to do this.
For
Yeah.
real, blah, 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 blah. Is it just
Oh,
the
it's
minus?
constant pair. Oh, that's easy.
Shall two numbers multiply to make alpha and beta... Sorry, multiply to make alpha, beta, add to make... Yeah, multiply to make C, add to make B. Okay.
Wait, are they conjugate pairs or not?
Conjugate pair, yeah. For
Okay.
real numbers, if the roots...
I just got confused because they wrote minus alpha and minus the other one. So I'm confused. But they are conjugate pairs.
Mm-hmm.
Okay. So it's just 7 minus 2i.
What is B?
Find the quadratic equation. Oh. Wait. Can you go back to the bit before?
Oh, you cheat this man.
Okay. So 49 minus 4i. I don't know if that's right, but it's that alpha plus beta.
4i?
Yeah, I'm not sure if that's right, but and then it's 4. Is that the quadratic equation?
No. Were you just multiplying them by each other, was it?
I don't know.
How
I
did you...
didn't multiply them.
What did you do?
In the one before, it said the middle bit is like alpha plus beta I. Oh, do you have to like actually add them?
You might be right. Hang on, find the quadratic equation. So alpha is that.
I think I'm wrong.
Alpha is 7
If you
plus
add
2.
them, you get 14. So I think but then it wouldn't be a quadratic because it would just be all numbers.
So alpha...
I really don't know.
I better check. So Z minus alpha.
This is confusing me.
So Z minus 7 plus 2 root I.
But what's Z?
Z plus 7... No, 7... Sorry, Z minus 7 minus 2i.
I'm going to do that.
And then Z is the answer.
Z squared.
Mm-hmm.
Oh, so it's just Z squared. And then 14i. I think. Because when you add them, you get 14.
14i.
And then I think it's minus 49, but I'm not sure. And then you have to multiply them. So you get 49. And then 53.
So essentially you're
It
multiplying...
says you have to multiply them, and it's a conjugate pair, so it's just different of two squares.
Okay.
I think you can just ignore the Z bit.
Okay.
So it's 53, not 49. Plus 53. I don't know. This is a bit confusing.
Calculator.
Right.
1 minus 14, 53. 7 plus 2i, 7 minus 2i.
Oh yeah.
And so we're correct. Z is x. So
Okay.
it's like
I was just getting confused because I was like, what is that? Where does it come from? But yeah, you just have to add them and then multiply them.
yeah, x minus a equals 0.
Oh my God, it's like that thing in algebra where you have to like, like the numbers have to add up to the middle one and then multiply to the end one. It's like the same thing. I just realized.
Yeah,
Oh my God, this is where algebra comes from or something, right?
kind of. See. It's quadratics in reverse.
Find the values of alpha plus. Alpha plus beta is minus 14. Wait, no, it's just 14.
Yep.
And then alpha times beta is 53. And interpret the results. What does that mean? It's 14.
Should it,
Yeah.
not, should it not be minus 14?
No, it's just 14.
Was it?
Because 7 plus 2i plus 7 minus 2i is just 14. The 2 i's cancel out, so you just have 14. Yeah, 14.
You cheat this man. 53. The constant term in the above equation is MB. What was the interpreting thing? The constant term.
That is the interpreting thing.
There you go. All right. Any questions there?
No, I mean it was a bit hard, but I get it now.
It's quadratics in reverse.
Yeah.
So if x is equal to something, it's
yeah,
like
I get it now.
Yeah, it's like factor theorem. Okay. Oops.
2 minus 3i is the other root.
Okay.
And then the equation is z squared minus 4. Okay. And then minus 5. Sorry, the middle one should be 4i and then minus 5. Wait, no, 4z, not 4i. Yeah, I'm getting confused. But yeah, it's equal to 0.
How could you check your answer?
Put it in the calculator and see. Oh. How do you make it I? Because I put 1 minus 4 minus 5 and it's giving me like answers. So
that means we're not correct.
Oh no.
Unless it's minus 4 minus 5. Yeah, that's just got real answers. That's not correct.
Yeah, that's wrong. I don't know.
Okay, what's wrong here?
No clue.
Z minus 2 minus 3i. Z minus 2 plus 3i. Z squared. Is it plus 4 as the C?
Do you think it would be plus 4? Because if you add them, you get minus 4. And it has to be minus alpha plus beta Z. So I think it might be plus 4. Minus 5.
So if you were to multiply them, that would be plus 4, wouldn't it?
No, if you multiply them, that's when you get like 5.
How'd you get 5?
I did 4 minus 9i. Wait, that's not 5. That's 13.
So 4.
Okay, it should have been 13 then.
Okay.
The last term should have been 13. I don't know. I'm like messed the whole thing up. Wait, why is it 4 minus psi?
I'm just messing around. Okay, so what was it? Sorry, z squared.
I don't know if it's minus or plus 4 and z in the middle. I think it's 4 though.
Plus?
Don't know. I think so.
Plus 4z
Plus 13.
13.
I'm going to check this. It still doesn't look right, but... Yay! Wait, no, it's not right. I think it should be minus 4z. I think it is, yeah, it is minus 4.
That's it. And so it is minus 4. Any questions there?
I mean, learn how to do it, but no, it's not really.
Yeah, just take your time with it.
Yeah.
You can always do it the long way.
I probably will.
Write it down, go through it. Okay.
I and then
This seems easier somehow.
so z squared minus 10i, no, 10z. Why do I keep saying I? No, it's z squared minus 10z. P is 10. Plus 26. Q is equal to 26.
Check.
It's correct.
Boom.
That one was a bit easier.
I think the numbers were a bit more straightforward, but same idea. Let me see. Given that there's one there is a quadratic equation, it's the same, isn't it?
Mm-hmm.
Okay. Same. All right, let's do this.
Oh, this is the one where you have to multiply by 3 plus I over 3 plus I.
Mm-hmm.
Which gives you 50 plus 5. I got 15 over 10 plus 5i over 10. Which can be simplified, but I didn't. Would they want me to simplify it?
I want you to simplify.
3 over 2 plus half I. Or I over 2.
No.
No?
A half I.
Why are you not meant to write I over 2? Oh, okay.
B.
Okay, it's a bit mean. So z squared minus 3z, and then multiply 4 over 2 squared. Ten over 4 plus 10 over 4. That does not look right. Anyway.
Can't be right.
Huh?
I think it has to be a whole number, does it? Go on, put it in your calculator.
Does it have to be a whole number? Why? No, it's 1.5 plus a half I. That's right.
So 10 over 4?
Yeah.
Um,
Why would it have to be a whole number? I didn't understand.
let's see, that was question 8. Hang on. Was it these ones? Is it a different question? 8? I guess from the next section, is it?
Okay.
Yeah, 10 over 4. Okay. Usually they have to be a factor, can't be anything other than a whole number. Let's see this one. Same?
Kinda.
Oh, it's a bit different.
So 25 minus q squared is equal to.
It's the same, it's the same, it's the same.
Okay.
Okay, roots of quadratics.
I understand it now.
Let's see. Solving cubic and quartic.
I have no clue how to do this.
Oh, it's a bit different. Given that -1 is a root, find the value of k.
Oh, you can just use like factor theorem for that.
Yeah.
If -1 is a root, then if you substitute 1, it has to equal to 0. Right? I think.
If you substitute -1, it would be 0. Would be 0, wouldn't it? As a bracket, it would be a factor would be z plus 1.
Okay. Okay. Yeah, if you substitute -1. So you can just do that and then solve. So you'd have -1 plus, wait, -1 again, -3. So k is equal to 5. Find the other two roots. I don't know what that means. I mean, I know what it means. I know how to do it.
Calculator.
Okay. -1, 1 plus 2i, 1 minus 2i. So 1 plus minus 2i. The other roots is that one.
What am I looking at here?
Polynomial division.
Wait.
Why does it ask me to do polynomial?
Did it? But what are the actual roots? Did I not? There we go. 1 plus 2i, 1 minus 2i. Great.
So you don't need to do polynomial division, right? Because I hate it.
We didn't, and we got the answer.
But it's like the proper method to do polynomial division.
There's a few different methods. You could long division, I suppose.
Oh, I don't like it.
Just calculator. Let's take a look.
This method is even more complicated, though.
Yeah, polynomial division. That's what they did, I think. Okay.
I honestly have no idea. I would just use my calculator to solve this.
Use your calculator to solve it. Yeah.
Because I don't know how to do it. it's thinking half minus 5, 3 plus I, 3 minus I.
So half minus 5, what was it?
3 plus I and 3 minus I.
And whatever this is, Z. So yeah, you could make one of the brackets Z minus 3 minus I, and then go from there. Another root is 3 minus I. So those are your factors. And then you just figure out the other one using division. Calculator.
It's really long. Show that it's a factor. Do you have to divide to show that it's a factor? Wait, no. I don't know how you show that that's a factor.
If it's a factor, Z squared plus 4, and then some other bracket.
So you do have to divide.
Not necessarily. Factor theorem.
Factor theorem.
If this is a factor,
Z squared minus 4 gives you 0.
So if this is a factor, then that is equal to 0.
Why would that be? Why would Z squared plus 4 be equal to 0?
Or hang on.
Wouldn't it be the other one says like minus 4? I thought that was how it worked with factor theorem.
Factor theorem. Hang on a second. Factor theorem. If it's
it's like f of minus 1 is a factor.
Factor, yes.
It's equal to 0. Then the factor is like x plus 1. Like I thought it was like the other way around.
So Z squared plus. So what is it? Z squared minus 4?
I don't know.
If a factor is
I'm going to try solving this though.
X minus 3, then a root is X equal. So I believe Z squared plus 4 is equal to 0.
Yeah. If you substitute Z squared plus 4 into that, it will give you 0, I think.
Quicker way. Z squared equals minus 4.
How does that show it's a factor, though?
Z equals?
Oh, yeah, then you just substitute minus... Wait, 2i? Is that right? Minus 2?
Plus or minus 2i?
Yeah. Wait, why would it be plus or minus? Oh, yeah, because you're square rooting.
And yes, you would sub that in, and you would get 0 for 2i.
How is that easier?
I don't know.
Oh, yeah, you don't have to do a binomial expansion.
So they
long
did.
Division. I told you it was long division.
Yeah, but okay, so they did long division. They got 0. That's called factor theorem. There we go. Z equals plus or minus
That's
2i.
not what factor theorem is.
Factor theorem means you don't have to use, like, so if you have a remainder.
Isn't factor theorem when you just reverse the sign and then it's a factor?
Yes. So if a factor was X minus 3.
Yeah, then 3 would be, if you put 3 in, it would give you 0.
Yeah, so then X minus 3 is equal to 0. X equals 3.
But it's not X minus 3 is equal to 0. It's if you put, isn't it if you substitute? Oh, wait, no, it isn't. Okay, I think I'm just confusing myself now.
I agree. This one.
Yeah, okay.
So it's the factor is equal to 0. Then you just solve it, and that's the root, and then you can just sub that in.
Okay. I solved the equation already on my calculator. So.
And is this what you got?
Yeah.
Nailed it. Yeah. So we got most of complex numbers done. How was that for you, Amogha?
It's like a bit hard, this bit, because I don't really get the factor theorem stuff that well.
To
go over factor theorem.
Yeah, factor theorem is easy.
I know how to do it by long division, though. I understand that. So.
So yeah, it's like the point of it is if you have to find the remainder of something divided by something else.
Yeah.
The quick way is you make it equal to 0, you get the root, and then you sub that in, and whatever the answer is the remainder. The special case is if the
Think I get.
remainder is 0, then that's the factor theorem.
Okay.
That shows it's a factor. So it's just a quicker way of, instead of having to do long division, make it equal to 0,
Yeah.
solve sub in. What are we doing next time?
I don't know. Some further maths thing, I guess.
Are you doing further maths?
Nope.
So why do you want to do further maths?
Just for fun.
Huh?
So I got bored of like the normal maths topics.
We could do like factor theorem, remainder theorem.
Yeah, I probably should go over that. But I don't think I'll need like a whole lesson on that because I do remember it.
Okay.
But like maybe just like a quick revision on that.
Okay, yeah, let's take a look at further maths then. Why are you doing maths in uni or?
Nope. It's just for fun.
Argand diagram.
I don't mind any topic.
This one could be good. Did we do this one?
Yeah, we did that last week.
Did that one? We could.
I don't like matrices because I did some in GCSE, so I vaguely remember it. But it's way harder.
What did you say about matrices?
I don't mind doing it.
Okay, we can do matrices. Why, do you have any idea what you'll do next year?
I've applied for biomedical science and got an offer, so
Okay.
yeah. But I'm taking a gap year anyway.
Sorry?
I'm taking a gap year anyway, so.
Oh, okay. Great. Yeah, any questions for me in general? All right, well done, Amogha. You did great. I look forward to chatting you again next week.
Bye.
Have a good week. Goodbye.